Hello there. Welcome to chemistry. Today is chemistry lesson 2.2. And today we're going to learn how to convert chemistry things, not just weird distances and times, but we're going to change grams into moles. We're going to change moles into grams. We're going to use and change moles into the number of particles. We're going to change the number of particles into moles, and then we're going to go a big step where we'll go from grams to moles to the number of particles, and the number of particles to moles to grams. So let's just get started on this. Grams to moles. All right, so if we're going to do grams to moles, let's get a nice pretty color to start with. That's what makes it work. All right. I'm making this problem up. I'm not really too worried about what it's going to be. I'm just going to make up something. So I'm going to say that we have, let's say, this is where I'd usually call out. I'm going to say 100 grams. 100 grams of, let's go easy, H2O. And you ask yourself, well, how many moles of that do I have? So we're going to go from grams to moles in this case. Okay, so grams to moles, that's our map already. I have it mapped out for us. Grams to moles. So we have to change grams into moles, and it's a one-step process. Now remember our factor label table. The key to this thing working out is to cross out your grams. So let's put grams on the bottom. And write labels. Please write labels. You're going to be graded on labels, so make sure you write them down. And then we're trying to change that into moles. Okay. Now, what we're going to do now, I'm not going to have enough room if I do it there, though, is we're going to find those conversion factors that work for us. How's that work? Right there. Okay, so we need the moles and the grams to be equivalent amounts. So how are we going to do that? So you have to ask yourself, how many grams are in a mole? Or how many moles are in a gram? And then you remember, you think, what is a mole? And then you say, oh yeah, Mr. Arnold said you just change the label to grams. You take the mole, you find the mass, change that label to grams, and that equals 1 mole. So in other words, 1 mole is equivalent to water's mass. So remember, it's 1 plus 1 plus 16. Oh my gosh, that equals 18. I know you guys know how to do this, so I'm just putting it up there just for fun, you know. So now we have 18 grams per 1 mole. A little saying I made up a long time ago. It's not a very good saying, but it says, if you're changing grams into moles or moles into grams, the grams mass comes from the periodic table, and 1 is going to be the moles. All right, so we're going to take 100 divided by 18. Boom, 5.5. 5.5 moles of H2O. Circle your answer. Label your answer, for goodness sake. Okay? That looks good. All right, we're going to reverse this. We're going to go from moles to grams. And so I'm going to make up another number. I'm going to pick carbon dioxide. I'm picking these because I know the masses, and I just, I want to do it the quick, easy way. So I'm going to say, let's go with, we're going from moles to grams. We're going to say that there are 2.6 moles of carbon dioxide. Ooh, that sounds exciting. How many grams is that? Again, we have to cross out moles. Moles on the bottom, CO2. We're converting it to grams of CO2. Okay, that's your setup. I wouldn't write numbers in until you have all your labels down. Now, how many grams are in a mole? If you have moles over grams or moles over grams or grams over moles, the moles is going to be 1, and the mass is going to come from the periodic table. So that's going to be 12 plus 16 plus 16 for those who didn't know that already, and that should be 44. All right, so this time we're going to multiply. That's why you have to have this table set up, so you know what to do, right? They're going to get more complex than this. This is the easy peasy way. All right, I got 114.4. And that would be grams of CO2. Again, the labels are so important. All right. Now, we're going to go and do something that it's not as practical, right? It's not a practical thing to do, but it's something that we do in chemistry to, I think, emphasize the importance of emphasize what a mole is, right? Because a mole is that mass in grams, but it just happens that the ratios all work out where it's the same number of particles every single time, right? So that number was, if you remember from class the other day, and I don't know if every class hit this the other day, but that number was 6.02 times 10 to the 23rd, right? That equals 1 mole. So that's the number of particles in 1 mole. All right, let's do this. It doesn't matter what compound we use now because we're not finding masses. We're just going right to the number. So we're going to say that we're going moles first. We're going to say we have 5 moles. Well, let's go water again, right, of H2O. Now we're going to find out how many particles are in those 5 moles, right? Straighten out for me. It didn't straighten out for me. Let's try it again. Now straighten out for me. There we go. And we're going to change this moles into the number of particles. So the first thing I'm going to do is I'm going to cross out that mole on the bottom. So mole H2O. All right. Now we're going to the number of particles. So I'm just going to use the hashtag moles, right? Follow me on Twitter. You'll see that it's on there all the time. Okay, so the number. So we have 1 mole of water contains 6.02 times 10 to the 23rd particles, right? I don't need a number sign there, do I? Right, weird label, but something that you're really rarely going to find. Why do you care how many water particles there are? You don't. Okay, so we're going to take and multiply that in. And I know what you're going to ask yourself, or what you're going to say right now. How do I put that number into the calculator? And well, hopefully, oops, I missed. I'm trying to give myself more space. There we go. And so here's how this goes into your TI calculator. We're going to put in 6.02. And then you're going to push second comma, which is the EE button. All right, so that's a button. When I do that, that's a button. It's second comma. Oh, that's semicolon. Second comma. Oh, now it's gone all the way. Second comma on your calculator if you have a TI-84 plus CE. If you don't, it may be some other thing, but you're looking for EE or EXP. All right, and then we're just going to put that number in, 23. All right, that's TI. Too much information? Yeah, I know. But that's TI, so that's how you're going to punch that in. If you're using an iPhone, which you may be using an iPhone, I know someone is because they left their calculator in here, and I have it right here. So if you did lose a calculator or leave one in class the other day, I have it. So on your, I'm punching in to make sure this is right. On your iPhone, you're going to put in 6.02, just like we did before. And then the EE button is down by the 1 if you have it. You have to have it turned sideways. And you push the EE button. And then you should be able to push in 23. Yep. and it's gonna look like this on the screen, 6.02 little e 23. All right, now, just get this clear. The EE, or the little e, is times 10, all right? So if you get this as an answer, it means times 10 to the 23rd, right? That's what that means. Don't put a times 10 into your calculator. Just use the EE. If you put a times 10 in there, you put 6.02 times 10 EE 23, you just added an extra decimal place, and you're going to be off, and you're going to miss every single one of them. All right. I'm going to move that down again for the 5th time. And this way I can do the problem. Oh, I guess I don't. I'll just write the answer here. Okay, so I got that in, 6.02 times 10 to the 23rd times 5. And so I'm getting 3, oops, let's try this one. Let's change colors up. 3.01, and this is what it says on my iPhone, right? But that's not how we're gonna write it. We're gonna write 3.01 times 10 to the 24th, okay? And I'm gonna say this one more time. This is this. All right, move on. Now we're gonna go back the other way. Okay, I'm not gonna do a bunch of calculator jibber jabber this time. I'm just gonna go and do it. So we're gonna say that, oh my gosh, what if we had 1,000,000? 1,000,000 particles. It could be anything. It could be marshmallows. It could be whatever. We have 1,000,000 marshmallows. How many moles of marshmallows do we have? Right, so there's the number. 6.02 times 10 to the 23rd goes on the bottom, and that's equal to 1 mole. And I'm doing this on the iPhone for some reason. There's 1,000,000 divided by 6.02, and then I have to turn it sideways. EE 23 equals 1.6 times 10 to the negative 18th moles. All right. Your number should be that on your paper. It'll say E in the calculator, but that's how we're doing it. Next step. All right, our last 2. All right, and get myself some space. This time we're going from grams to moles to the million. All right, so I'm going to just pick something randomly. Let's say sodium chloride. We all know that, right? So let's go to, what do you think? Brown? Okay, we'll do it. So we're going to make up a number here. We're going to say that we have 4 grams of NaCl. Now we're going to change that to moles. Moles is the middleman. That's where you're going to go. That's the change. Moles is going to be in the center. Moles is what's going to make it happen. Moles is what's making it possible. So use moles in the middle when you're not sure. It always go gram to moles, and moles a number. Moles is the middleman. You can't go from grams to the number straight out. You need the middleman. So we have a 3-stepper. 2, 3 steps. Okay. So we start off with what we're given. 4 grams NaCl, right? We're changing that to moles of NaCl. I would write it above because I didn't give myself enough room. And then we'll go to the number, and I'll just write that, NaCl. Okay, so we have to cross out grams NaCl, moles NaCl. Now notice that I'm not writing any numbers in yet because it's a no-brainer right there. Let's just do the part that we can do straight out without writing anything down. Now we have to do some math. We have sodium chloride. So that's Na is 23 and Cl is 35. According to my calculations, that should be 58. So there's 58 grams in 1 mole. In 1 mole, there are 6.02 times 10 to the 23rd particles, right? Now, I'm back to a TI this time, right? Oops, not graph, I just want it on normal. Okay, so here's what we're gonna do. In your calculator, you're gonna take 4 divided by 58. You won't need parentheses as long as you do it this way. Times 6.02 second comma, that's our E button, 23 equals. And I'm getting 4.1, I'm just gonna 5, there we go, times 10 to the 20, or from the 22. And that's going to be the number of particles of NaCl. Uh-oh, there we go. Thought I was losing my pen here. All right. One more to go, just the opposite way. I'll give us the number of particles. We'll just say that we have 3.01 times 10 to the 23rd, right? And we'll figure out how many, we'll just stay with NaCl. Now let's find out how many grams that is. So, we have the particle number, and we'll go to moles. Moles is the middleman, and then to grams. And these are all NaCl. Okay, cross out the number. Cross out the moles, and let's punch in our stuff here. So we have 6.02 times 10 to the 23rd, 1 mole. 1 mole is, remember, 58 grams. That's why we use the same thing. So look it up again. Now, if you notice, when I picked that 3.01 times 10 to the 23rd, that's a half a mole. So we're going to get an answer of half of that gram. At least it should. 23 divided by 6.02 E23 times 58, enter, and I got 29. Okay, hey, that's it. I'm not going to talk any more about that. I'll let you go. There's the worksheet. It should follow the same patterns. Use these maps. I gave you 6 really nice maps to use. And show your work. Show your work, right? The answers are included on the back page, but it's not showing any work, and the answers are there. I know the answers, you know the answers. Just make sure that your work works out so you can do this when it counts, when it's on a test. Okay, that's all I got to say. Have a great day, and hopefully we'll be back together.